what makes the purpose of light? What makes the purpose of light? We clearly say that if the light is present, we can see an object. For suppose you people are seeing me because the light is adjusted. The light is adjusted. Whereas, what about this one? The light gives us the purpose of clear vision. The light gives us the purpose of a clear vision. So, in short, light is a form of energy which is useful for a clear vision, and this is the most important definition. And while coming to our next part, in order to understand the light, we have to understand the basic principle of light. What is that light principle? This is called as Fermat principle. The principle of light is called as a Fermat principle. So, what is the meaning of a Fermat principle? Let us understand a smaller example. See, a substance is at A. A substance is at A, and of course it is traveling to B in a path that is straight line. A substance from A to B is traveling in a straight line, and let us assume the time taken for that is 5 seconds. The time taken for that is 5 seconds. Whereas, let us compare another object which is starting from C. And this is traveling in whirling path to D. So, the starting point is a C, whereas the ending point is a D. So, automatically it is taking a whirling path. Thus, the time taken here is nothing but 10 seconds. Naturally, the distance is high. The time taken is also high. So, according to the Fermat principle, it states that light always travels in a straight line, or light always travels in a path which takes least time. So naturally, light always travels in a path which takes least time. This is nothing but linear path, that is straight line path. So this principle was given by a scientist called Pierre de Fermat. And based on him, the name of a scientist, the principle is named as a Fermat principle. So, Fermat principle is the indication that Fermat principle says as that light travels in a path which contains least time. It importance most the time, not a distance. So, this is nothing but a Fermat principle. And this is a very important one-mark question, dear students. This is a very important one-mark question. Number of times, what is Fermat principle? The question is asked. So, everything you have to mention in terms of points. The first point, you have to keep a heading, that is called as Fermat principle. And first point, it was given by a scientist called Pierre de Fermat. The name of a scientist is the first point. Second point, you have to reveal the principle. What is that? Light travels in a path which takes least time. So that ends the marks. That ends the answer. Automatically you are going to get 1 mark. No deviation in that. So, in order to understand more properties of light, let us go back to the properties of light. More clarity gives us more information. So, here, light is a very common word which we use here. Light is a very common word which we use. In order to understand the properties, let us first study about first property. This is nothing but called, I have drawn a straight line. What does it mean? Because it's a most important property. I just didn't draw a straight line normally. Light always travels in a straight line. This is a symbol for that, and this property is referred as rectilinear propagation. The property of light which discuss about the movement of a light. rectilinear propagation. It's a most and important property of light. This is first property of light. And while coming to our next, up to what? Always the light travels in straight line? No, there are some exemptions. What are the exemptions? Let us understand. If any obstacle is placed, for suppose, if any obstacle is placed, namely A, B. Let us suppose an obstacle called as AB, which is nothing but opaque substance. All of you dear students, you people might have known what is the meaning of an opaque substance. Opaque substance is nothing but which cannot allow the light to the other side. Opaque substance cannot allow the light to the other side. This is an important definition, and this is an important definition which I am going to say. You listen carefully please. So what about if the light is traveling in a straight line? The light is traveling in a straight line, and of course the arrow marks are most important. That gives us more information. So here, when a light ray is incident on an opaque substance, the original path of a light is to travel like this. It has to cross the other side. But being this as an opaque substance, it cannot travel to the other side but reverses its path and bounces. Reverses its path and bounces. This bouncing back phenomenon is nothing but called as the second property, which is referred as a reflection. So my dear students, this is a basic most important property in your syllabus. That's called as first lesson. Reflection of a light through curved surfaces is our first lesson. So in the total chapter we are going to study the reflection phenomenon, which is related to various mirrors or objects. So once let us recall the definition of a reflection. So listen, the reflection is nothing but when a light ray, what is this light ray called as? It is incident on an object. Therefore, this light ray is called as incident light ray, or you can also call it as incident ray. No issue with that. Whereas the light ray which is bouncing back is referred as reflected light ray. Is referred as reflected light ray, or you can also call it as reflected ray. So this is important here. What is this? When an incident light ray is allowed or passed on opaque substance, as it cannot allow the light to pass through other side, the light bounces back. So bouncing back of a light ray in the opposite direction, in the same plane, dear students, this is below the plane, this is another medium, so it is traveling in the same medium but in opposite direction. It's not crossing the medium, it's not coming down. That's an important. So what about this phenomenon is referred as a reflection. This phenomenon is referred as a reflection. And my dear students, remember that, do remember that reflection is a characteristic phenomenon of only opaque substances. You cannot expect this reflection phenomenon in other type of substances like transparent and translucent. Only you can expect a reflection in opaque. This was a bit question asked, so I am repeating this many number of times. Which objects possess the reflection? Which objects possess the reflection? Option A, transparent. Option B, translucent. Option C, opaque. Option D, none of the above. So the correct answer, students, is nothing but an opaque substance. It is nothing but an opaque substance. So, dear students, let us understand the reflection phenomenon in detail. So dear students, we are going on to the first and basic most property, that is nothing but opaque substances. Opaque substances and their examples. Opaque substances and the examples. See, we can take the best example of an opaque substance as mirror. And of course, every day we see our face in a mirror. Every day we see our face in a mirror. Are we good enough? Are we white enough? Are we fair enough? Oh, is our hairstyle ready? All the things we set in a mirror. By seeing in a mirror, and of course we see a larger number of mirrors, a bigger size of a mirrors. So this is an example of a opaque substance. This is an example of opaque substance. And one more condition, dear students. What is the other condition a mirror definitely should have? It should have a highly polished surface. It should have a highly polished surface. So dear students, if these two conditions are satisfied, that is a substance that is called as opaque substance, which is highly polished surface, which is having a highly polished surface, then it can be regarded as a mirror. And of course, the mirrors are of two types if we go on for the classification. So, the mirrors are majorly two types. Listen my word carefully dear. I am using a word. Mirrors are majorly two types. Listen at the ending of my class. What the word I say? Because here there is a small differentiation. Listen carefully. The mirrors are majorly two types. What are they? The first one is called as plane mirrors. The first one is called as plane mirrors. Whereas while coming to second one on the other side, it is nothing but called as spherical mirrors. Then what is the differentiation between plane and spherical mirror? Let us understand it. Listen carefully. A plane mirror has no curvature or bending. It's like Eiffel Tower, straight enough. It's like Eiffel Tower, straight enough. No bending is seen in that. This is like no bending is seen in a plane mirror. You can make no bend. You can also use the word curvature. Curvature is not seen, cannot be seen. Whereas if you come across a spherical, here we get some curvature, here we get some curvature. What is that curvature? Maybe of two types. Maybe of two types. This is, we expect a curvature. Yes. Curvature is S. Here the curvature is no. You cannot. Whereas based on if inner curvature is seen, then it can be referred as concave mirror. It can be referred as a concave mirror. Whereas if in opposite factor outer curvature is seen, if outer curvature is seen, what is that? It is referred as convex mirror. It is referred as a convex mirror. So my dear students, just one small thing I would like to inform. The mirror is an opaque substance which is having highly polished surface. And listen my word. Now what the sentence I am using? Because of this I am repeating it number of times. Mirrors are generally two types, majorly two types, plane with no curvature, spherical with a little amount of curvature. And based on this, the spherical mirrors are again of two types. If a mirror has inner curvature, then it is concave. If a mirror is having outer curvature, that is nothing but a convex. So generally, out of all the classifications, mirrors are of three types. Plane mirror, spherical concave mirror, spherical convex mirror. So these are the things we have to study in detail. We have to study in detail. So let us come back to our topic. This is called as inner concave, outer convex. How do they exhibit their own style? Let us exhibit this one. So my dear students, here I'd like to go on for this concept. This is nothing but just now we have said one point that the mirrors are of generally mainly two types. The mirrors are mainly of two types, that is plane mirror, spherical mirror. And of course, if you know the total classification, you can judge it by mirrors are of three types. What are the three types of mirrors? First one is nothing but plane mirror with no bending. Second one, slight bending, that is nothing but spherical mirror. And in the spherical, if it is inner, it is nothing but a concave. If it is outer, it is nothing but a convex. So now let us understand what are the properties related to concave mirror first of all. Then we go for the next. You listen carefully, dear. Let us come back to concave. And of course, what is it? What is this? Is it a lens or a glass or what? It is mirror. It's a concave mirror. So listen carefully. What is a concave mirror? Just now we have discussed. Concave mirror is a spherical mirror. Concave mirror is a spherical mirror in which we are able to see the inner curvature. We are able to see the inner curvature. Let us exhibit with a diagram. How does it show the inner curvature? Let us take the figure. So actually, you remember friends, this could be your plane mirror. This could be your plane mirror without any bending. But if you cut a portion inside, if you cut a portion inside, naturally it looks like a cavey substance. And this is referred as a inner curvature. If this is a case seen, then it is nothing but called as a concave mirror. And of course, majority of the cases we are going to deal about the concave mirrors in our syllabus. Mana syllabus lo, we study most of the examples by using concave mirror. And also we study the examples which we occur through a convex mirror. So, a spherical mirror with inner curvature, that is cavey part, is nothing but a concave mirror. Now let us understand, if for the same plane mirror, if you attach an outer attachment, if you attach an outer extension, then it forms like this. Then it forms like this. It's a bulging surface, bulging curvature. This is called bulged. So this is nothing but called as a convex mirror. This is nothing but called as a convex mirror. And of course, naturally it has outer curvature. Outer curvature. Dear students, just now I am saying that it is an inner curvature. We have cut it part. We have bited it. Whereas here I am attaching outer side. Therefore, automatically if you cut this, this converts like this. If you attach it, it converts like this. So here we are able to see a concave mirror, that is a spherical inner curvature. If we are able to see outer bulged curvature, then it is called as a convex mirror. Now let us understand. What is that? process taking place in concave, at the same time convex mirrors? So dear students, just now we have said, that is, what are the process taking place? And it's just like arranging our food. So in order to arrange our food, we go to market, we take our vegetables, we plainly take our vegetables according to the need, and then we cook, we clean, and we serve. So the same process is going on here also. In order to understand the procedure taking place in concave and convex, we have to learn about the terminology first of all. We have to learn the terminology. And of course, we better know that what is the meaning of a terminology. Terminology is nothing but it is whatever the keywords related. The keywords related to the topic are nothing but called as terminology. This here we are able to understand. This is nothing but the first is nothing but a pole. The first is nothing but a pole. So, whatever the terminology we are discussing purely is only according to the spherical mirrors. Dear students, remember this, because we are studying a topic. This is nothing but reflection under curved surfaces. So, a curved surface is nothing but can be example as a mirror, that to a spherical mirror. So, all the terminology we are relating to the spherical mirrors only. So let us take for our convenience an example or a diagram, rough diagram. Let me take a rough diagram. Here, if suppose naturally this could be your concave side, how can you say? Automatically you can say this is KV surface, it has gone in. So you can by easily say that it's a concave. So everywhere, whether it may be a lens or it may be a mirror, midpoint, every object has a midpoint, and that midpoint can be referred as a pole. The midpoint can be referred as a pole. So what is a midpoint of any mirror or lens? It can be called as a pole. Midpoint of a mirror can be called as pole. And of course, listen, every time we cannot write pole. So we shortcutly abbreviate it as P, capital P dear. Don't write it as small p because it goes in a different meaning. So what about here? Here a line is going to pass. A line is going to pass through the pole. A line is going to pass through the pole, and this line is referred as principal axis. This line is referred as a principal axis. Listen, we have learned two definitions. What are the two definitions? These are the starting foundation basics. See, midpoint in the mirror is referred as a pole. It can be abbreviated by capital P. Whereas the line which is passing through the pole is nothing but called as principal axis. This is second definition. And of course, my dear students, you listen carefully. This is nothing but a midpoint. And of course, if you place any object here, let us suppose an object is placed here. Let us suppose it might be a candle. Let us suppose it might be a candle. Naturally, from the light source, the candle emits a light. The candle is going to emit the light. What type of light? In the form of rays. In the form of rays. That is, already you people know, light always travels in straight line. Thus, the light rays are going to travel in straight line and hit the mirror here. And of course, here the rays, as it cannot pass through this side, they are going to be reflected. They are going to be reflected. And of course, number of rays are going to pass. This you see, of course, if any ray is coming from down, listen dear students, I have committed a mistake here. What is the mistake? I have mentioned an arrow mark here. But here I did not mention any arrow mark. So dear students, what I want to say in terms of this type of topic, that is spherical mirrors or reflection or light rays process, what you draw is not important. What you indicate is important. That is, here if you don't draw this arrow mark, totally useless. So take care while writing examination. Because in a classroom you can correct it, or your teacher might say, okay, but in an annual examination, such type of things may cause you major damage. Right? So, what the mistake I have done? I have to correct it. That is, I have mentioned a ray that is coming from outside to hit here. So naturally, this is also reflected. I did not commit the same mistake. Here I have mentioned the arrow mark. That is, the light is coming like this. Did you observe anything here? And of course, the mathematics students definitely, those who have an interest in mathematics, definitely identifies this portion where the reflected rays are going to meet. The reflected rays are going to meet, and this portion can be referred as focus point. Focus. The reflected portion can be referred as a focus. What is this? This is an intersection. In your math language, it can be called as intersection. Like our chaurastas, where many roads combine to form at one common position. So, all the reflected rays are going to join or intersect at this point. This is nothing but called as a focus. And of course, focus can be indicated by capital F. Don't go for small f. Because whatever the next definition I am saying, you listen to that. So, this is pole. This is pole. And of course, this is focus. You listen me. From pole to focus, there lies a small distance. Here roughly 10 centimeters of my scale, but actually it might be millimeters, nanometers. So what about the distance between pole to focus? The distance between pole to focus can be referred by another word. This is called focal length. This is referred as a focal length. So, what is a focal length? Focal length is nothing but the distance between pole to focus. Here I mention a word F. And this is nothing but small f. So, don't go for confusion. Capital F, focus point, fixed point. Small f, focal length, it's a measurement. So, don't go for this one. Don't go for a confusion. So till now, how many definitions we have cleared? Point number 1, it's a pole. Midpoint in the mirror is a pole. Point number 2, the line passing through the pole is called as principal axis. Point number 3, when you place an object, all the what? Incidental light rays meet the mirror and form reflected light rays. These are going to intersect a point. These are going to intersect at a point. This is nothing but called as focus. This is nothing but called as a focus, indicated, abbreviated by capital F. Listen the difference. Indicated, abbreviated by capital F. This is a third. While coming to fourth definition, this is focal length. What is a focal length? Focal length is nothing but the distance between pole and focus. Distance between pole and focus. Acha, I'll just give you a small example. This is a little bit confusion to the students. What is that? What is focal point? My dear students, don't get confusion. Don't get confusion. Focus, focal point, both are same. Focus and focal point, both are same. That is, we can call this point as a focus or otherwise a focal point. No need of any confusion. Right? Why I am mentioning this? Sometimes the question may be asked, the distance between pole and focal point is dash. Then you think, our sir didn't say. You say naturally. So, don't get confusion. This is focus, this is focal point. Both are same. Right? So, we have discussed 4 examples, that is 4 terminology point, and the 2 points we are going to discuss now. Dear students, just now we have discussed 4 definitions. But before going to that, I just would like to give you one small concept so that we can understand the later 2 definitions. Overall, we have 6 definitions. Out of that, 4 are completed. Before going to the last 2, I just would like to remind you one small concept. What is that? Listen. What are normals? I'm not asking English terminology, normal, you're normal, this is normal. I'm not asking that. I'm asking physics terminology. What are normals? Normals are nothing but imaginary lines. Normals are nothing but imaginary lines. That means they're not really existing. They are imaginary lines. So see, first let me take again a diagram of a concave mirror, that is spherical mirror. So what about here the active side, and don't forget to mention pole, and don't forget to draw principal axis. This is P, this is principal axis. Never forget this. Never forget this. In this corona situation, sanitizing our hands is most important. The same manner, writing these terminology is also most important. The most important, we have to mention it. Without that, our diagram is useless. So what about, we have taken a spherical mirror. And of course, we have taken a pole. We have taken a principal axis. And of course, the active side of a mirror is this side, side number 1. Active side. The passive side, where the light cannot make a differentiation, is second side, this side. So, if you take normals, these are said to be the normals. Dear students, how I am drawing? Note the difference. I am not drawing a straight line. If I draw a straight line, a real existing. Whereas I am drawing dotted lines. Dotted line is nothing but imaginary lines. You see, all these lines are meeting at a point. All the lines are meeting at a point. And this point is nothing but called as C, not big C. It is just C. That is nothing but center of curvature. It is nothing but center of curvature. So, you people might get a small confusion. What is that? The normals are going to intersect at a point, and this is called as center of curvature. If light rays are going to intersect, that point is called as focus. That point is called as a focus. This is a small differentiation. Do not get confusion here. If the reflected light rays converge or intersect, then it is called as focus. If normals are converging or intersecting, then it is called as center of curvature. This is the most important difference. Do not get confusion. And here also, in between fixed point P and in between fixed point C, we have a small distance. We call it as PC. Dear, it is not personal computer. It is the distance between pole to center of curvature can be regarded as radius of curvature. Radius of curvature. This is an important schedule. See, radius of curvature is also indicated by a letter R, capital R. So, in this schedule, we have learned pole P. Principal axis is normally written, whereas center of curvature C, radius of curvature R, capital R. Next is focus, capital F. Next is focal point. Lastly, small f. So, these are the 6 terminologies related to spherical mirror. One by one, in a speed manner, I just recall this. You see, pole is a midpoint of a mirror. The line passing through the pole is called as principal axis, and all the normals are going to intersect, and this is called as a center of curvature, and the distance between pole to center of curvature is called as radius of curvature, and of course all the incident or reflected rays join at a point called as focus, and the distance between pole and focus is called as a focal length. These are the 6 points. Okay students, we will be continuing the topic. This is nothing but what about a procedure or process taking place in a convex and concave mirrors. So dear students, let us come back to our topic. Just now we have discussed the terminology related to spherical mirrors, and now we would like to go on for the process exhibiting in the spherical mirror. That is, in a home, what are we going to do? What the process is going to run? Our entertainment, our care, and also our feeding by our loved parents. In a school, what happens? Our education is going to be occurred. This is nothing but called as a education. And here also, in a concave and a convex mirrors, we are going to suppose some process, some procedure. What is that procedure? Let us come across. Acha, this is concave. Now, let us go on for the next one. This is nothing but a convex. Of course, here we are going on to the process differentiation. So, I have written side by side. So, listen. Just now we have discussed what is that? This is a pole. The line joining it is called as principal axis. Let me mention, otherwise you get a confusion. And all the rays are going to meet at one point. Such a type of all the rays meeting at a point can be referred as a convergence. can be referred as a convergence. So what is the meaning of convergence? Many light rays coming into one. This you can exhibit in a magnifier. And of course, in a magnifier, you people and even ourselves also have played many number of games, taking a paper, taking a small piece of matchstick, and again concentrating it with sunlight. That is, the total sunlight rays are concentrated at the one point, and this can be referred as a convergence. What is the use of convergence? Energy is increased. Energy is increased. How? Let us take ray A, ray B, ray C, ray D, ray E. All the rays are supposed to contain 10% energy. 10% of energy. This is A contains 10%, B contains 10%, C contains 10%, D contains 10%, E also contains 10%. Then all the rays are meeting at this point, right? Then shall I say all the energies are focused here or met or combined here? That means at this point, how much energy can you expect? 10, 10, 10, 10, 10. Overall, 50% of energy is expected at single point. At single point, you can expect this. Thus, energy is increased. If energy is increased, what happens? Clarity of image is increased. You see the most clearer images. This is a most common phenomenon taking place in a concave mirror. Whereas we come across the opposite. This is called as convex. What is that convex? Let us draw first. And of course, when you consider this one, naturally the same process exhibit. Midpoint is called as a pole, whereas the line passing is called as a principal axis. The line passing is called as a principal axis. But here, due to the outward bulging, what is going to happen? A light focused at the center, deviates into many rays. You observe the difference. In the concave, all the rays are meeting at one point. On the contrary, the energy rays which are existing at one point deviates. This is only with respect to rays. So what about if suppose, let us take, this process is nothing but called as convergence. What could this process call as? It is called as divergence. It is called as a divergence. So the process exhibiting in a concave mirror is convergence, whereas the process exhibiting in a convex mirror is divergence. And what happens here? The light energy increased or decreased? The energy is decreased. Naturally, if we see 50% of energy here, what happens at this? 4 rays or 5 rays divided into 4 by 5. 4 or 5. Naturally, each ray contains 10 or 12%. So if you see the image at 50% image, it will be more brighter. If you see an image at 10 or 12%, naturally it will be duller. It will be somewhat blurred or shaky. So what about this one? Here, image clarity decreases. Image clarity is going to decrease. At the same time, energy is also going to decrease. Thus, we expect a little amount of small differences here. So, let us understand this is nothing but a convex, this is nothing but a concave, this is nothing but a convex. What are the process exhibiting here? In a concave, we are exhibiting convergence, meeting all at a point. This is a convex, we are exhibiting divergence, dividing into many rays. So, what happens for the next? what this is able to enhance, how we are able to obtain an image, in what, how can I see my face, how in a concave mirror, how in convex mirror. All that, stay tuned, we'll be continuing in the next class. Don't go away, you're watching ABC Education and Learning app. Thank you.